everyone, my name is Judy Hoffman. I'm from UC Berkeley. Today I'm going to be presenting Learning with Side Information through Modality Hallucination. This is joint work with Saurabh Gupta and Trevor Darrell, also at UC Berkeley. And I just want to do a brief mention to another poster that we have presenting tomorrow on cross-modal distillation for supervision transfer. So the point of this work is to study the problem of transferring or adapting between RGB and depth information, or more generally just between different imaging modalities. We focus here on RGB and depth because we know that there are very successful RGBD object detection models which significantly outperform both the RGB and the depth independent counterparts. And what this tells us is that actually there's distinct and also complementary information that can be learned from these two different imaging modalities. Unfortunately, depth information is not always available at test time, and so what we do here is we want to focus on learning to actually extract this sort of complementary information that you would have been able to gather from a depth image, except only doing it with our RGB image. And the way we're going to do this is by learning to transfer information at training time from the depth network to the RGB networks. And we do this through modality hallucination. So the way that this works is we first start out by training an RGB CNN network using standard supervision loss. We then do the same for our depth network. And now actually comes the meat of it, which is that we want to produce this hallucination network. So the point of this network, again, is to be able to encapsulate some of the information that would have been created from the depth network. So to that end, we include a hallucination loss. And the way that this loss works is its actual method is to be able to enforce that you regress the mid-level hallucination activations towards the depth mid-level activations. So at the end of the day, when you actually enforce this loss, you can learn a simultaneous RGB detection model, which has both the standard RGB supervised network, as well as this hallucination loss, which should encode and mimic some of the depth mid-level activations that would have been present for the same paired depth image would it have been available. We evaluate our algorithm on the standard NYUDV dataset. And here what we're going to do is we're going to use RGB and depth images in order to train our hallucination network. But then at test time, we're going to do our evaluation on just RGB images. So here I've presented some results, and of course at the poster session I'll be happy to discuss more. And what we see is that with our RGB and hallucination network, we're able to actually produce a stronger joint model than just the RGB model alone, as well as stronger than if you were to produce an ensemble method of two different RGB models that were trained using standard supervision. So this is really telling us that actually through incorporating this hallucination loss, through using this extra side information in the form of depth in this case, we can inform our RGB detection model and improve it overall. And here I have two example qualitative images which show how these actual performance improvements manifest themselves in terms of detection. I'd be happy to talk about this more at the poster session, which will be later this afternoon, as well as, once again, please see our cross-modal distillation paper.